Okay, so let's go through the review for Unit 8. So we have all of our key formulas here. You want to have those written down on your formula sheet, as well as all of this useful information. So I would definitely copy all of this information down so you can have it as a reference when you take your final. So number 1 and 2. So it says the town of Cooperstown has 3,000 people. 6% leave. So we're starting out with 3,000. That's your p-value. Your r value, you always change this to a decimal. So it would be 0.06. And because they're leaving, that means we have to subtract the rate. Okay, so your a value, which you want to type in, you want to type in your 3,000. And then because they're leaving, you have to include that minus sign. So you want to put minus 0.06. So your equation essentially is 3,000 parentheses 1 minus 0.06 to the power of t. So how many people will be left in 7 years? So using that formula, let's go ahead and substitute in 7 for t. And see what you get. And you want to round it down, round to the nearest person. So there should not be a decimal in your answer. So you can enter 1945 people. That's how many people will be in the town. And again, you should not put you should only put digits. So just type in 1,945. When we're looking at number 3, we have to write an equation given the table. So the first thing to remember is you have to start with 0. So when I'm looking at these numbers, it looks like they're dividing by 4. So the b value, my multiplier, is 1/4, or you can write that as a decimal. Your starting value is not 800 though, because we need to go back 1. So if I go back 1 by multiplying 800 by 4, then my starting number is 3,200. So y equals 3,200 times 0.25 to the power of x, or you can use 1/4. And because the numbers are getting smaller, this is an example of decay. For numbers 5 and 6, this table already begins with the 0. So a is 3. I don't have to go backwards. B is what I'm multiplying by, and the numbers appear to be doubling, so I'm multiplying by 2. So my formula would be y equals 3 times 2 to the power of x. These numbers are getting bigger, so this one would be growth. Can't really see it, but at the bottom we would select growth. Number 7, we have Marvin. This is 18th birthday. On the day he was born, his grandmother invested $500 into a special account that earned 7.5% annual interest. How much is it worth today? So A is going to equal how much was invested, which is 500, and it's earning 7.5%. So that would be 1 plus 0.075. So you always just divide by 100 to convert that to a decimal. And that's going to give you your R value of 0.075. And this account was in there until his 18th birthday, so T is 18. So substitute that in your calculator. And you should get, don't include your dollar signs, you should have $1,837.90. Looking at number 8, what kind of function would best model the data? If you look at this, this is repeated addition. We're adding 4 repeatedly. And the function that represents repeated addition is linear. So if you have the same first difference or repeated addition, this would be a linear function. Linear functions are repeated addition. Exponential is repeated multiplication. Alright, so let's go ahead and look at this one. So we go from 10 to 5, that would be minus 5. And then we went from 5 to 2, that's going down 3. And then we go from 2 to 1, that's going down 1. And then we go from 1 to 2, and that's going up 1. So these are all different, so we know that it's definitely not linear. And it's not repeated multiplication, so it's not exponential. So let's see if we have a common second difference. From -5 to -3, that's a positive 2 difference. From -3 to -1, again, that is a positive 2 difference. From -1 to +1, again, that is a positive 2 difference. So you have a common difference of 2. And because your common difference, your common second differences are the same, then it is a quadratic. So you have same second difference. Numbers 10 and 11, we are going to use our formula for compound interest, and that is one of the formulas that was listed at the beginning, and this is the one we're going to use. Remember, you can use Decimal Scientific Calculator. So we have 5,000. The interest rate is 6%. Is compounded daily, so that's 365 to the power of 365 times 7. Go ahead and type that in your calculators. So for number 10, if you type that in your calculator, you should have $7,609.55. Alright, so we're going to do the same thing in question 11, except now it's compounded quarterly. And that's going to change the end value to 4. So for question number 11, we're going to type in 5,000, 1 plus 0.06 over 4 to the power of 4 times 7. Let's go ahead and type that in your calculators. See what you get. So you should have $7,586.11. So when we look at number 12, let's compare the transformations. We started off with y equals 3 to the power of x, and then that was transformed to g of x. So let's see what happened when we compare. We went from this point here. This is the point of reference to this point. So the h value, because it went to the right 5, the h is 5. So if I were to count from here, I have to go to the right 5, and then I also have to drop down 4. So that would mean that k is negative 4 because I went down. Okay, so my formula, remember when you're typing it into your equation though, the h value sign flips. So h is positive 5, so I'm going to put a minus 5 in that first box. K is negative 4, and that is a minus 4. So it says the number of fire ants triples. So that's the key word that tells me I'm using this formula. This is my formula for multipliers that are not decimals. So after 16 hours, there were 2,025 ants. So that means when x is 16, y is 2,025. And it tripled, so that means that my multiplier b is 3. So let's substitute these three numbers in and solve it for a. So we have 2,025 equals a times 3. Oops, and I almost forgot something really important here. It says every 4 hours. That's really important. So we actually need to take that x and divide it by 4. Because it takes 4 hours for it to triple. So we have 3 to the power of, and then x is 16 over 4. So I'm substituting in my x, and I'm substituting in my y. So x, and then my y goes here, and then my multiplier b goes here. So when we simplify this, we have 2,025 equals a times 3 to the 4th. 2,025 equals A. So let's simplify 3 to the 4th, and we get 81. And then our last step is to divide by 81. So 2025 divided by 81 is 25. So that was how much I started off with. That's my initial amount of ants. So the answer to 13 is 25. So we need to write our function rule. And in our first box, we're going to type A, which is 25. In the second box, we type B, which is 3, because it's tripling. In the third box, we type C, which in this example is 4, because it triples every 4 hours. So now that we have our equation, we can use that equation to answer number 15. So how many fire ants will there be in 38 hours? So let's go ahead and substitute that in the equation. So we're going to take 25 times 3, and then we're going to type in 38 over 4. So let's type that in, and we're going to round to a nearest whole number. So if you type that in your calculator and we round to the nearest whole number, that would give us 852,299 ants. And you don't need to type in the word ant. So let me take that off because Canvas will mark it wrong. I think it's only going to allow you to type in a number. Okay, so let's look at number. So for number 16, we have two graphs that are reflected over the y-axis. I'm going to go ahead and select that. That is your transformation for number 17. So now let's talk about how do you write your equation when it reflects. You have two different options. You can make your exponent negative, which would be 10 to the power of negative x, or you can write the base as a fraction, which would be 1 over 10 to the power of positive x. So g of x, which is this graph here, when we look at this graph from left to right, g of x is decaying. So g of x is an example of decay, where q of x is an example of growth. So number 19, we need to go ahead and select all that apply. So first thing first, I'm noticing that we can multiply my exponents. And if I multiply my exponents in my denominator, negative 2 times 2, I will get negative 4. So let's select that as an answer. The next thing I am noticing is, in this example, if we take the c to the -6 and move it downstairs, it becomes positive. That's what happens from here to here. So let me go ahead and order these. So this would be your first step. This is what happens second. The third thing we want to do is move our d upstairs. So this would be your third. And then it would be simplified. So that's marking the steps of simplification. And those are all equivalent to our original. Number 20, we're going to use continuous interest, which is PERT. So we have $1,000 to start off with. So we have 1,000 in the first box. And the interest rate is 5%. So 0.05, because you have to change that, is your R value. And that goes in the second box. So for number 21, you're going to type in 1,000 e to the power of 0.05, and it's in 4 years. So type that in your calculator, see what you get. So if you type that in your calculator, you would have $1,221.40. And again, you do not include, let me start over. So if you type that in your calculator, you have $1,221.40. Okay, so we're at the last few questions here. So let's look at question number 22. So we have an A value. A is 1/2, which is going to make it vertically compress. Your H value is +1, which is going to make it move to the right 1. Your K value is +4, which is going to shift it up 4. All exponential functions, we have a horizontal asymptote, and it's going to occur at y equals k. And in this example, k is 4. Your domain for every exponential function is all real numbers. Your range is k to infinity. So let me go ahead and summarize that. Just a reminder, for Unit 8, we had horizontal asymptotes, and they occur at y equals k. Your domain is going to be all real numbers for all exponentials, and your range is k, whatever your k value is, to infinity.